Welcome to the deep dive. Today we are putting on the fast shoes, really digging into something that might just change how we think about efficiency in AI.
Yeah, it's pretty exciting stuff.
We're diving into MiniMax M2. It's an open source model specifically designed as a 10 billion parameter AI agent.
And the key there is agent. It's built for work.
Exactly. It's not about being the biggest model on the block. It's engineered to be, fast, practical, and the sources we have suggest it's actually challenging some much larger models.
The big ones, yeah, like the GPT-5 class competitors.
So our mission today is really a shortcut for you, the listener, if you care about utility, not just the hype surrounding these things.
Right, cutting through the noise.
We're going straight to the source material, looking at its design philosophy, then hitting those specific performance benchmarks.
And the pricing tables, which are quite revealing.
Yeah, absolutely. We need to see if it really is that economic game changer people are starting to talk about. Basically, is this the model for constant, heavy-duty agent work?
I think the signs point that way. What's really fascinating is the laser focus on deployment strategy. It's not playing the general knowledge game.
No encyclopedias here.
Not really, no. It's all about pragmatic agent stuff. Code review, using tools effectively, making deployment repeatable, and crucially, affordable.
Like a surgical strike against high costs and latency.
That's a good way to put it.
Yeah.
You know, the source material says, a small, fast model is starting fights in big weight classes, and it is not bluffing. I like that.
That really sums it up. Okay, let's unpack this then. Starting with that core idea, the engineering behind its speed, the mini advantage, right? So the genius, if you want to call it that, of MiniMax M2 seems to start with its design constraints. The philosophy feels simple, right? Keep the active parts small.
Keep activation small, yeah. That directly boosts throughput.
Which makes the agent feel responsive, instantaneous almost.
Exactly. It's built for that grind, the back and forth of coding workflows, debugging, testing.
So what's the mechanism? How do they actually achieve that speed?
It's the mixture of experts layout.
Yeah.
MOE. Now, the total size of the model, like on disk, it's pretty big.
Okay.
But, and this is the critical number, only about 10 billion parameters actually fire up or activate for each token processed. That's the core activation set.
10 billion active. Got it. And that's what dictates the runtime speed and cost.
Precisely. Think of it like this. A big traditional model is like a giant factory where every single machine turns on for every tiny task. Super inefficient for small jobs.
Right.
The MiniMax M2 MOE is more like an assembly line with lots of specialist stations. But only the few specialists needed for that specific task, say fixing this Python function, actually wake up and work.
So you get the power of all those specialists, potentially.
Yeah, the collective expertise is there. But you only pay the runtime cost, the latency penalty, for the small group that did the actual work on that token.
Okay, and that directly connects to so what's for you, the person running these agents? Lower latency.
Much tighter latency, yeah.
Yep.
And importantly, much lower bills.
Which then lets you run more tasks in parallel on the same budget.
Exponentially more, potentially. Especially if you're using an API.
Think about a typical coding agent session, maybe in CI/CD. It tries an edit.
Runs tests.
Fills.
Oops, okay. Runs a shell command to see what's up.
Tries again. Maybe the network was flaky, that whole loop.
Right. The real bottleneck there isn't usually the model's genius on the first try. It's the speed of each of those follow-up steps. The iteration speed.
And because MiniMax M2 keeps those activations small.
It just returns faster on each little step. Your CI loop doesn't grind to a halt waiting for the model.
So the agent can afford to take, say, a dozen small corrective steps.
In the time, a bigger, slower model might manage only 3 or 4. Yeah, It's designed for iteration speed over getting it perfect in one shot.
Okay, speed is great, but it needs to perform, right? Especially for tool use. Let's get into the data.
Yes, the numbers. We've got 2 key tables in the source material that tell the story. Benchmarks and pricing. Let's tackle the benchmarks first. The MiniMax M2 benchmarks overview table.
Right. Looking at this table, what jumps out?
Well, first, notice the type of benchmarks. These aren't just, trivia quizzes or language understanding in isolation.
No.
No, they're focused on end-to-end workflows. Things like tool use, working in a terminal, handling multi-file edits. These signal agent readiness. Can it actually do complex stuff?
Gotcha. So let's pull out some key numbers for developers, the ones who'd actually use this to ship code. First one, SWE-bench verified. It scores 69.4.
Which is a very solid score, what that means practically.
Yeah, what does 69.4 mean?
It means the model can reliably fix real issues found in actual GitHub repos. And crucially, it can verify those fixes using the project's test suites.
So it's good for refactoring tasks, bug hunts in existing code.
Exactly. It suggests it can handle the messy reality of existing code bases.
Okay, what else is critical here? Terminal bench score is 46.3.
Right. And this is important because agents working on code often need to use the command line, running scripts, installing things, checking files.
A model that trips over npm install isn't very useful.
Precisely.
Yeah.
So 46.3 suggests it's pretty stable in the shell, it can execute commands reliably, and, maybe more importantly, recover if things go wrong in the terminal session. It shows resilience.
Now, this is interesting. The scores for complex reasoning look high. The bench, that's tau squared, right?
Yeah.
For extended reasoning plus tool use, it's 77.2.
Yep.
That seems really strong.
It is. It suggests the model can maintain a logical chain of thought even when using tools over multiple steps. It doesn't just derail itself mid-task.
But then look at BrowseComp. That's for web-aided tasks. It's 44.0. That feels lower. If the agent needs to read documentation or look up error messages online.
Yeah, that's a fair question. Is 34.0 a weak spot?
Could the speed be hiding brittleness when it has to deal with external, maybe messy web data?
It's a good point to raise,
Yeah.
looking at the source materials take on this.
Yeah.
44.0 isn't top of the leaderboard, true, but it's not a failure either.
Okay.
The interpretation seems to be that MiniMax M2 prioritizes connecting the steps into a workable plan over perfectly understanding every nuance of some massive web page in one go.
So it's more about navigating and finding the next step, less about deep comprehension of the page content itself.
Kind of. It's reliable enough to browse, grab what it needs, cite it, and figure out the next action in its plan. It's less likely to just, face plant when reading docs, even if it doesn't absorb every detail instantly. For a code agent, sticking to the plan might be more valuable than deep web research skills.
Okay, that makes sense. So the overall takeaway is consistency across these different types of agent tasks. Coding, terminal, tools, basic web use that matters more for teams than just acing one specific leaderboard.
Exactly. It's engineered for consistent workflow execution step by step.
All right, let's shift from the benchmark numbers to, well, the real world. What are early users actually seeing day-to-day use? Because this is where it gets interesting, right? The rough edges often tell you as much as the successes.
Absolutely. We've gathered feedback, kind of synthesized it into pros and cons. On the good side, users are reporting it really does excel at that grind we talked about. Complex, multi-file edits, big refactoring jobs that run for a while, and especially those run until the tests pass loops. They feel composed, intentional.
Not just randomly flailing.
Less so, apparently. And its recovery, when things go wrong, like a dependency error or a flaky test, it's described as pragmatic, like a focused coworker just trying the next logical thing.
Okay, sounds promising. But what about those rough edges? We need to be clear about the downsides people should expect. You mentioned it overreaches. What does that look like?
Right. So the first rough edge is probably expected. It's world knowledge outside of tech, STEM fields. It's okay, but not amazing. Don't ask it to write poetry about ancient history.
Fair enough.
The second one is that tendency to overreach. You might ask it to fix one specific broken function, and it might decide to refactor the whole class it lives in, or add some related feature you didn't actually ask for. It gets a bit enthusiastic sometimes.
Okay. So it tries to be too helpful.
Something like that. But there's a way to handle it.
Which is crucial, right? What's the fix?
The source strongly recommends using tighter prompts. Don't just say fix the bug. Be specific. Produce a minimal diff for this file addressing this specific error.
Give it guardrails.
Exactly. And maybe ask for an outline or plan first, then ask it to execute that plan. Constrain its scope.
Okay, that makes sense. Now let's connect this practical use back to the money, the economics. We need to look at that MiniMax M2 pricing overview table. This is where the speed meets affordability.
Yeah, this is pretty wild. Input tokens, 0.3 zeros per million. That's $0.3.
30 cents per million tokens in, and output?
Output is 1.2 zip per million tokens, $1.20.
Wow. Okay, put that into context for us. How does that compare?
I mean, we're often talking about costs that are, maybe 50 times cheaper, even 100 times cheaper for certain high-throughput agent tasks compared to some of the big closed-source models people often use. It's a different ballpark.
50 to 100 times cheaper. And there's also that promo offer.
Oh, right. Free API usage until November 7th, 2025.
That's a long free trial. Gives teams a huge runway to test it out, integrate it, see if it works for them without spending anything on the API calls themselves.
Absolutely. And this pricing strategy, it fundamentally changes the game for continuous agent loops. That's the key.
How so?
Well, think about that whole cycle again. Review code, try and edit, run tests, maybe debug with a shell command, try again. That might burn through, say, a few 100,000 tokens in total.
Well,
With this pricing. That entire loop might cost just a few cents. Literally.
2 cents per loop.
Yeah. Which means you can actually afford to let the agent iterate. You can embrace that many small steps approach without constantly worrying about a huge bill racking up. That cheap iteration is the engine. It unlocks the agent workflow.
All right, so it's fast, it's capable in key areas, and it's cheap to run. How do people actually get it and use it? Accessibility.
The options are pretty broad, which is good. There's a web playground for quick tests.
Standard stuff.
Yep. Then there's proper API access, which is key for automation. And crucially, there's local deployment. The weights are open, available on Hugging Face.
And that open weights part is huge for some organizations, right? Compliance, privacy.
Oh, absolutely. If you have strict data policies or can't send code to external APIs, being able to run it locally on your own infrastructure is non-negotiable. Open weights enable that.
Okay. And for API users, how easy is it to integrate? Do you need a whole new SDK?
Actually, no. This is another smart move they made. The API is designed to be Anthropic-compatible.
Meaning?
Meaning, if you've already built code or an agent framework that talks to, say, Claude,
Yeah.
you can basically just swap in MiniMax M2 by changing the base URL endpoint and the API key in your existing code.
Yeah.
Your existing Anthropic SDKs should just work.
Ah, that's clever. Lowers the barrier to entry significantly.
Definitely designed for low-friction migration.
Yeah.
Get people using it quickly.
Okay, now, usage tips. We need to cover the best practices from the source material. The things that make the difference between it being just okay and actually great. What's the absolute must-know?
The number one absolutely crucial thing is about preserving the model's internal thought process during multi-turn conversations.
It's internal thinking. What does that look like?
You'll often see these blocks of text, maybe formatted like XML or JSON, sometimes bracketed by 4 dots like bait stuff. That's the model basically thinking out loud, planning its next step, its internal scratch pad.
Okay, like chain of thought prompting, but internal to the model's process.
Exactly. And the critical point is, you must capture these reasoning blocks and send them back to the model as part of the conversation history in subsequent turns.
Why is that so vital? What happens if you strip them out?
If you strip them out, you're essentially forcing the model to forget how it got to its current state. It has to restart its internal planning from scratch every single time you talk to it.
Ah, so it loses all the context of its own reasoning.
Completely. And for complex, multi-step agent tasks, that absolutely tanks performance. The coherence just falls apart. So keep those reasoning blocks in the history. Always.
Got it. Critical tip. Any other key prompting advice?
Yeah, a couple more quick ones. First, for file edits, try asking for a short plan first, then specifically ask for a minimal diff patch.
Why minimal?
It helps ensure you get clean, targeted changes, rather than the model trying to rewrite huge chunks of the file, which can be messy.
Yeah.
Atomic batches are better.
Makes sense. And temperature settings.
For general agent flows where you want some creativity but still grounded reasoning like planning or complex problem solving, the recommendation is temperature 1.0.
1.0. Okay.
But if you need absolute precision, like a surgical code fix or a guaranteed deterministic output, drop the temperature way down close to 0.0.
Okay. High for creative reasoning, low for precision. Got it. So summarizing the model's alignment,
Yeah.
it feels very purpose-built.
It really does. It's aimed squarely at being that reliable AI coding assistant you can actually afford to run constantly, all the time.
So it shines in places like CI helpers, repo triage, maybe long-running terminal sessions doing automated tasks.
Exactly, those kinds of workflows. It's probably not going to replace your senior architect for deep system design or your marketing team for creative copy. That's not its niche. Hashtag outro.
Right. So we've covered a lot of ground here. We looked at that big speed advantage from the 10 billion activation MOE.
Super efficient.
We validated its skills with strong coding scores, like that 69.4 on SWE-bench.
Showing real-world capability.
And we confirmed the pricing really is potentially revolutionary for making these continuous agent loops affordable, cents per loop.
Game-changing economics.
So wrapping it all up, what does this mean for you, the listener, in your day-to-day workflow?
Well, the final verdict seems to be, think of MiniMax M2 less like some all-knowing universal oracle and more like a really efficient, reliable colleague.
A colleague focused on coding and tools.
Exactly. An affordable, pretty robust, and importantly, open solution that's tailored to excel specifically at code generation, tool use, and agentic workflows. It works because it's designed to just keep making progress, taking thousands of those small, cheap steps towards getting the job done.
That idea of momentum, of cheap steps, feels really key. Okay, here's a final thought. A provocative action item inspired by the source material for you to consider.
Okay, let's hear it.
Try setting up a dedicated test repository. Give this agent full permissions within that controlled environment, let it touch files, run the actual tests, even browse documentation via the API if needed.
A real
A
sandbox.
real sandbox. Then, for a week, be rigorous. Track the metrics that matter. What's the success rate per step? How many tokens does it actually consume per fix? How long does it take the agent to get a task from identified to validated green?
Measure the actual impact.
Exactly. If after that week the workflow feels smoother, if your human team is genuinely spending less time bogged down in the small iterative churn, then this model has probably earned its keep.
A practical trial.
Yeah. Just consider how many thousand small steps toward done, as the source puts it. This kind of cheap, fast iteration could save your team over the next